We're going to talk about reaction stoichiometry. Reaction stoichiometry deals with the situation when we're given a specific reaction and we're asked to determine how much reactants are consumed and or how much products are produced. So let's suppose we have a hypothetical reaction. 2A plus B yields C. And we were asked, if 1 mole of A was consumed in the reaction, then how many moles of C were formed? What we say is that there is a 2-to-1 mole ratio of A to C. We get these numbers from the coefficients in front of the balanced reaction. Since the mole ratio is A to C, we take the coefficient of A, which is 2, and put it in front of the coefficient of C, which is 1. The coefficient in front of A is 2, and the coefficient in front of C is 1. From this, we can say half the moles of A that are consumed are produced as moles of C. So if 1 mole of A was consumed, then 1/2 moles of C were formed. In general, if the mole ratio is X to Y, then multiply the moles of reactant by Y divided by X to get the moles of product. So here, our reactant was A, and the mole ratio of A to C, where C is our product, was 2-to-1. So our mole ratio was 2-to-1, which means X was 2 and Y was 1. We simply multiply by Y over X, or 1/2, to get the moles of product. So we multiplied 1 by Y over X, or 1/2, to get 1/2 moles of C formed. This also works for any other reactant in the equation. If 2 moles of A was consumed, then how many moles of B were consumed in the reaction? We see that there is a mole ratio of A to B of 2-to-1. The coefficient in front of A is 2, and the coefficient in front of B is 1. X is 2, and Y is 1. So we multiply 2 moles of A by Y over X to get 1 mole of B consumed. This can all be generalized into this statement. If the mole ratio is XA to YB, then multiply the moles of A by Y over X to get the moles of B. A and B are any reactant or product in the chemical reaction. X is the coefficient in front of A in the balanced reaction, and Y is the coefficient in front of B in the balanced reaction. Let's look at an example of how we use this. Let's say we're given a question where we have a reaction. PbO plus NH3 yields Pb plus N2 plus H2O. And we're asked, how many grams of NH3 are consumed in the reaction of 8.16 grams of PbO? Step 1. Balance any reactions given or described. In any stoichiometry problem, or any problem where a reaction is given or described for that matter, your first instinct should always be to check if the given reaction or described reaction is balanced. If we look at the reaction given here, we can see that this equation is not balanced. For one, we have 1 atom of N on the left side and 2 atoms of N on the right side, so we know that we need to balance this equation. This is extremely important because even if you know the techniques to solve a certain stoichiometry problem, if you don't have the correct balanced equation, then you will get the wrong answer no matter what. So we're going to balance this equation to 3 PbO plus 2 NH3 yields 3 Pb plus N2 plus 3H2O. The equation is now balanced. Step 2. Convert any givens in mass to moles. If we look at our givens, we see that we have 8.16 grams of PbO. This is in mass. We need to convert 8.16 grams of PbO to moles. How do we do this? We divide 8.16 grams of PbO by its molar mass of 223.199 grams per mole, which is equal to 0.037 moles of PbO. Step 3. Define A, B, X, and Y. Since we have the moles of PbO and we are looking for the amount or the moles of NH3, A is PbO because it's the moles we have, and B is NH3 because it's the moles we're looking for. From there, X is 3 because X is the coefficient in front of A. In this case, A is PbO, and PbO has a coefficient of 3 in front of it in the balanced reaction. Y is the coefficient in front of B, or the coefficient in front of NH3, which is 2. So Y is 2. Step 4. Multiply the result of step 2 by Y divided by X to get moles of B consumed or produced. The result of step 2 was the amount of moles of PbO. So we're going to multiply 0.037 moles by Y over X, or 0.037 times 2 over 3. We do that here to get 0.025 moles of NH3 consumed. NH3 is consumed because it's a reactant. If we were solving for a product, then we would be having moles produced. But in this case, we consume 0.025 moles of NH3. Step 5. Convert moles of reactant to product, or reactant or product to mass if required. In this case, the question is asking for grams of NH3. We have moles, so we're going to have to convert it to mass. We convert 0.025 moles of NH3 to mass by multiplying NH3, the 0.025 moles of NH3, by 17.031 grams per mole, which is the molar mass of NH3, to get 0.426 grams of NH3 consumed. The question is now answered. Let's look at another question. Same reaction, but the question now states, if 928 grams of Pb are produced in this reaction, how many grams of N2 are formed? Step 1. Balance any given reactions given or described. We've already balanced our reaction, so this step is not necessary. Step 2. Convert any givens in mass to moles. We look at our givens, we see that we have 928 grams of Pb. That's in mass, so we need to convert 928 grams of Pb to moles of Pb. We do this by dividing 928 grams of Pb by 272.2 grams per mole, which gives us 4.479 moles of Pb. Step 3. Define A, B, X, and Y. In this case, we are given moles of Pb and we're looking for moles or mass of N2. So since we have Pb, Pb is A. And since we're looking for N2, B is N2. X is the coefficient in front of A, or Pb, which is 3. and y is the coefficient in front of b, or N2, which is 1. Step 4. Multiply the result of step 2 by y divided by x to get moles of B consumed or produced. The result of step 2 was that we have 4.479 moles of Pb. We're going to multiply that by y over x, or 1 over 3, to get moles of B, or moles of N2, that are produced. We do that here. 4.479 moles times 1 over 3, which is y over x, to get 1.493 moles of N2 produced. N2 is produced because it's a product. Step 5. Convert moles of reactant or product to mass if required. In this case, it is required, since we're asked for how many grams of N2 are formed. We do this by multiplying 1.493 moles of N2 by its molar mass of 28.014 grams per mole to get 41.824 grams of N2 produced. Let's try another question. Same reaction, but now, how many moles of N2 are produced when 907 kilograms of PbO are consumed? Step 1. Balance any reactions given or described. In this case, we've already balanced our reaction from before, so we don't need to do anything. Step 2. Convert any givens in mass to moles. If we look at our givens, we see that we have 907 kilograms of PbO. So we have to convert 907 kilograms of PbO to moles. We do this first by converting 907 grams of PbO to grams. 907 kilograms of PbO is 907,000 grams of PbO. We then divide 907,000 grams of PbO by its molar mass of 223.199 grams per mole, and we get 4,063.6 moles of PbO. Step 3. Define A, B, X, and Y. Since we have moles of PbO, A is PbO. Since we're looking for moles of N2, B is N2. X is the coefficient in front of A, which is PbO, which is 3, and Y is the coefficient in front of B. In this case, B is N2, so Y is 1. Step 4. Multiply the result of step 2 by y over x to get moles of B consumed or produced. So we're going to multiply the result of step 2, which was that we have 4,063.6 moles of PbO, by y over x, which in this case is 1 over 3. 4,063.6 moles of PbO times 1 over 3 gives us 1,354.5 moles of N2 produced, which answers the question. Step 5. Convert the moles of reactant or product to mass if required. In this case, we don't have to, because the question asks for moles. The question is completely answered, and we don't have to do any more step 5. Let's do another question. How many grams of H2O are made when 14.4 grams of N2 are formed? We're given the same reaction, different question. Step 1. Balance any reactions given or described. We're still dealing with the same reaction that's already balanced, so we don't need to do anything. Move on to step 2. convert any givens in mass to moles. We look at our givens, we see that we have 14.4 grams of N2, which is in mass. We must convert 14.4 grams of N2 to moles. We do this by dividing 14.4 grams of N2 by 28.014 grams per mole, which is the molar mass of N2, which is 0.514 moles of N2. Step 3, define A, B, X, and Y. Since we have moles of N2 and we're looking for moles of H2O, A is N2 and B is H2O. We have A, we're looking for B. We have N2, we're looking for H2O. X is the coefficient in front of A, or N2, which is 1, and B, or rather Y, is the coefficient in front of B, which in this case is the H2O. The coefficient in front of H2O is 3. Step 4, multiply the result of step 2 by Y divided by X to get moles of B consumed or produced. The result of step 2 was that we had 0.514 moles of N2. We now multiply this by Y over X, which is 3 over 1, to get moles of B produced, or moles of H2O produced. We multiply 0.514 times 3 over 1, which is Y over X, to get 1.542 moles of H2O produced. Step 5, convert moles of reactant or product to mass if required. In this case, it is required because we're asked for grams of H2O and we have moles of H2O. We have 1.542 moles of H2O and we need to convert that to grams. We multiply 1.542 moles of H2O by 18.015 grams per mole to get 27.779 grams of H2O produced. Let's move on to another question with a completely different reaction. Here we're given a reaction 2C8H18 plus 25O2 yields 16 CO2 plus 18 H2O. And we're asked how many moles of CO2 are produced when 451 moles of C8H18 is burned. Step 1. Balance any reactions given or described. Here we're given a reaction that's already completely balanced for us, so we don't need to do any work. Step 2. Convert any givens in mass to moles. We look at our givens, we see that we have 451 moles of C8H18. It's not in mass, it's already in moles, so again the work is done for us. We have 451 moles of C8H18. Step 3. Define A, B, X, and Y. We have moles of A, we want moles of B. We have moles of C8H18, we're looking for moles of CO2. Therefore, A is C8H18 and B is CO2. X is the coefficient in front of A, or C8H18, which is 2, and Y is the coefficient in front of CO2, which is B. The coefficient in front of CO2 is 16. Step 4. Multiply the result of step 2 by Y over X to get moles of B consumed or produced. The result of step 2 was that we have 451 moles of C8H18. We then multiply 451 moles of C8H18 by 16 divided by 2, which is Y over X. 451 moles times 16 divided by 2 is 3,608 moles of CO2 produced. CO2 is produced because it's a product. Step 5, convert moles of reactant to product to mass if required. In this case, we're asked for moles of CO2. We have moles of CO2, so we don't need to convert anything to mass. Let's look at another question with the same reaction. How many moles of O2 are consumed in the combustion of 585 moles of C8H18? Step 1. Balance any reactions given or described. Here, the reaction is given and it's already balanced, so we don't need to do any work. Step 2. Convert any givens in mass to moles. We're given 585 moles of C8H18. Since that's already in moles, we don't need to do any work to convert it to moles. So we have 585 moles of C8H18. Again, the work is done for us. Step 3. Define A, B, X, and Y. Since we have 585 moles of C8H18 and we're looking for moles of O2, A is C8H18, B is O2. X is the coefficient in front of C8H18, which is 2. Y is the coefficient in front of O2, which is 25. Step 4. Multiply the result of step 2 by Y divided by X to get moles of B consumed or produced. We multiply 585 moles of C8H18 by 25 divided by 2, which is Y over X, to get 7,312.5 mole of O2 consumed. O2 is consumed because it's a reactant. Step 5. Convert moles of reactant or product to mass if required. Since we're asked for moles of O2 and we calculated moles already, we don't need to convert anything to mass. How many moles of H2O are produced when 188 moles of C8H18 is burned? Step 1. Balance any reactions given or described. The reaction is already balanced. Step 2. Convert any givens in mass to moles. We're given 188 moles of C8H18, so we're already done with that step. 3. Define A, B, X, and Y. We have moles of C8H18. We're looking for moles of H2O. A is C8H18, B is H2O, X is the coefficient in front of C8H18, which is 2, Y is the coefficient in front of H2O, which is 18, and we're done. 4. Multiply the result of step 2, which is 188 moles of C8H18, by Y over X. In this case, Y over X is 18 over 2. We multiply 188 moles times 18 over 2 to get 1692 moles of H2O produced. H2O is produced because it's a product. Step 5. Convert moles of reactant or product to mass if required. The question asks for moles. We already calculated moles. No more work needs to be done. How many grams of C8H18 are consumed when 2.2 times 10 to the 4th moles of O2 is consumed? Step 1. Balance the reaction. Already done. Step 2. Convert any givens in mass to moles. Already done. We have 2.2 times 10 to the 4th moles of O2. Step 3. Define A, B, X, and Y. We have moles of O2 and we're looking for moles or mass of C8H18. We have O2, A is O2, B is C8H18 because we're looking for B. X is 25, it's the coefficient in front of O2, and Y is 2, it's the coefficient in front of C8H18. Step 4. Multiply the result of step 2 by Y divided by X to get moles of B consumed or produced. The result of step 2 was that we had 2.2 times 10 to the 4th moles of O2. We're now going to multiply that by Y over X to get moles of C8H18 consumed. We multiply 2.2 times 10 to the 4th by 2 over 25, which is Y over X, to get 1,760 moles of C8H18 consumed. Step 5. Convert moles of reactant or product to mass if required. Since the question asks for grams of C8H18 and we have 1760 moles of C8H18, we must convert 1760 moles of C8H18 to grams. We do this by multiplying 1760 moles of C8H18 by 114.232 grams per mole, which is the calculated molar mass of C8H18, to get 201,048 grams of C8H18 consumed.